We continue reading through the manual, Electrical Safety Student Manual. Section 4, Overview of the Safety Model. What must be done to be safe? Use the safety model to recognize, evaluate, and control hazards. Use the 3-stage safety model. Recognize, evaluate, and control hazards. To be safe, you must think about your job and plan for hazards. To avoid injury or death, you must understand and recognize hazards. You need to evaluate the situation you are in and assess your risk. You need to control hazards by creating a safe work environment, by using safe work practices, and by reporting hazards to a supervisor or teacher. Report hazards to your supervisor or teacher. We have a picture here of someone doing electrical repairs. If you do not recognize, evaluate, and control hazards, you may be injured or killed by the electricity yourself. Electrical fires are. Let me read that again. If you do not recognize, evaluate, and control hazards, you may be injured or killed by the electricity itself, electrical fires, or falls. If you use the safety model to recognize, evaluate, and control hazards, you are much safer. We look at each element separately. Recognize hazards. The first part of the safety model is recognizing the hazards around you. Only then can you avoid or control the hazards. It is best to discuss and plan hazard recognition tasks with your co-workers. Sometimes we take risks ourselves, but when we are responsible for others, we are more careful. Sometimes others see hazards that are overlooked or that we overlook. Of course, it is possible to be talked out of our concerns by someone who is reckless or dangerous. Don't take a chance. Careful planning of safety procedure reduces the risk of injury. Decisions to lock out and tag out circuits and equipment need to be made during this part of the safety model. Plans for action must be made now. So we must recognize electrical hazards and don't listen to reckless or dangerous people. Here we see the word hazard. The hazard is the object and the situation that can cause harm. We also see the word risk. Risk is the chance that an accident will occur, whether it is low, medium, or high. Lockout. To lock out means you turn off the power source by opening the circuit. It could be a pull knife switch that you pull down to open the circuit, or a circuit breaker in a cabinet, or some other means. Then what you do, you close the cabinet and lock it. It may be a padlock that you put on it. It may be a lock that you place on the handle. That's the lock out, to ensure that someone else does not come and close the circuit while you're working on it. The tag out means you place a tag warning others not to try to close the circuit because someone is working on it. OSHA regulations, the NEC NFPA 70E standard for electrical safety in the workplace, and the National Electrical Safety Code NESC provide a wide range of safety information. Although these sources may be difficult to read and understand at first, with practice they can be very useful tools to help you recognize unsafe conditions and practices. Knowledge of OSHA standards is an important part of training for electrical apprentices. See the appendix for a list of relevant standards. Remember, OSHA is the Occupational Safety and Health Administration, NEC, the National Electrical Code, and NFPA, the National Fire Protection Agency. These are bodies existing in the United States of America. You see the lock here, always lock out. See the lock, the padlock placed on the cabinet, and tag out. You see the tag here with danger and additional information written on it. So someone has opened the cabinet and turned off the main switch, then closed the cabinet and locked it and placed this tag on it, because they're working on the circuit. And if you do this, make sure you don't leave the key somewhere else or give somebody else the key. You must keep the key yourself. And if you're going to work on this same circuit and you see a lock there, make sure you place your own lock there as well. 2. The second element, evaluate hazards. When evaluating hazard, it is best to identify all possible hazards first, then evaluate the risk of injury from each hazard. Do not assume the risk is low until you evaluate the hazard. It is dangerous to overlook hazards. Job sites are especially dangerous because they are always changing. Many people are working at different tasks. Job sites are frequently exposed to bad weather. A reasonable place to work on a bright sunny day might be very dangerous in the rain. The risk in your work environment need to be evaluated all the time. Then, whatever hazards are present need to be controlled. Evaluate your risk. The third element is to control the hazard. Once electrical hazards have been recognized and evaluated, that means once you see them and you examine them for their potential dangers, they must be controlled. You control electrical hazards in 2 main ways. 1. Create a safe working environment, and 2. Use safe work practices. Controlling electrical hazards as well as other hazards reduces the risk of injury or death. Take steps to control hazards, create a safe workplace, and work safely. So we have an overview of the safety model. One way to implement the safety model is to conduct a job hazard analysis, JHA. This involves development of a chart, 1 column, breaking down the job into separate tasks, and 2, column 2, evaluating the hazards of each task. So note, you have the separate task listed Then you evaluate the hazard of each task, and then 3, in column 3, development of a control for each task. Example below. Job hazard analysis. Changing a wall ground fault circuit interrupter, GFCI. Task analysis. You will remove the cover. You look at what can go wrong while you remove the cover. Electric shock from exposed live wires. What do? You must de-energize by opening circuit breaker or removing fuse. Next task you will do, removing old GFCI. The hazard analysis. In other words, what can go wrong? Possible other live wires are in the opening. Hazard. Test wires with appropriate voltmeter to ensure all wires are de-energized. So you can use a voltmeter or an approved voltage indicator. The next task, installing the new GFCI. Hazard analysis. Possible connecting wires incorrectly. The hazard abatement. Check wiring diagram to ensure proper connections. The next task that you will do, replace cover and re-energize. Hazard analysis. Possible defective GFCI. Hazard abatement. Test GFCI. Now, a GFCI, ground fault circuit interrupter, is a plug that detects the difference between the current going out and the current going back in. The current going out to the appliance must be the same as the current coming back in. Now, if the current going out is a little higher than the current going back in, generally, if there's a difference of 5 milliampere, then an electronic circuit inside the GFCI will detect this difference and trip. That means it cuts off the current, and it does this within 1/40th of a second. Now, this 5 milliamp or more that is missing from the current coming back in could possibly be flowing through a defective tool, through somebody's hand, through their body, and down back to earth. So that is why the GFCI protects you from getting an electric shock. Now, GFCIs must, by standard, be installed within 6 feet of any kitchen sink, face basin, any water container, wash tub, or a wet area. If any plug is to be installed near to those areas, within 6 feet of those areas, it must be a GFCI. Now, use a safety model to recognize, evaluate, and control workplace hazards like those in this picture. We can quickly say a few. For example, loose wires. It can cause a trip. Right? You have ladders being close to the work area. You have an extension cord going right around around the longer distance instead of the shorter distance, and around more obstacles than necessary, and so on. You could look for others, but we'll move on. Summary of Section 4. The 3 stages of a safety model are: Stage 1, you recognize the hazards. That means you look for dangerous situations and objects. Stage 2, you evaluate the hazards. That means you consider what could go wrong while you're working. And 3, you control the hazards. That means you do something, whether it is removing the hazards or putting a barrier around them, or carefully examining them and making adjustment to reduce the chances of an accident or injuries. Section 5. Safety Model, Stage 1, Recognizing Hazards. We will look at Section 5 in a separate video.